test, see problems that specifically ask for you to demonstrate the product rule, or problems that ask you to demonstrate power rule 2 or power rule 3, so on and so forth. But you need this information to be able to work the problems that will be on the test. Okay, so you have to understand this because we're going to use it multiple times throughout the semester. All right, with that being said, remember we talked about exponents in class. All right, now when it comes to using exponents within the problems, there are rules that we can apply just to make using the exponents easier. So for exponents, we always want our exponents to be positive. And the first one we're going to look at is called the product rule. And the product rule says when I'm multiplying powers of like bases, I want to keep the base and I'm going to add the exponents. Alright, so you can see in this problem here, I have a to the m power times a to the n power. And so to perform that operation, the fastest way to do it is to use the product rule. And I just keep the base a, and I take the two exponents, m and n, and add them together. Alright, so for a more specific example, we have 2 squared times 2 cubed. Alright, 2 squared is 2 times 2, and 2 cubed is 2 times 2 times 2, and you can work it out like that, but that's rather lengthy. So this rule lets us shorten it up a bit, and we can just keep the 2, and then use the exponents 2 and 3 and add them together to get 2 to the 5th power. And then if we were working a problem out, we would evaluate that out to be 32. Alright, the second rule is called the power rule. And the power rule says if I have a base raised to a power and it's raised to another power, all right, so to raise a power to a power, then what I do is I multiply the exponents. So here I have 4 to the 5th power, and then I want to raise that to a 3rd power. So that means to take, remember exponents say take the base and multiply it times itself that many times. So in this case, 4 to the 5th would be our base. We'd multiply it out. The fastest way to do it would be to take 5 times 3 and get 15. And then you would use your calculator and you would enter 4 to the 15th power. Let's see if I can get it entered in right. Alright, and it's a really large number. Alright, so that looks to be like 1,073,741,824, so that's a fairly large number. Mainly what I want you to remember is that if you have a power raised to a power, you multiply the two powers together. Alright, the second rule is also a power rule where I'm going to be multiplying exponents, but in this case there are multiple exponents inside my base. So here I have a and b, they each have an understood exponent of 1. So I'm multiplying 1 times m and 1 times m to get a to the m, b to the m. So an example would be if I had 7x and then raised to the 3rd power. So remember this 7 has an understood 1 and this x has an understood exponent of 1. So if I take and I say 1 times 3, I would get 7 cubed. And then once again, 1 times 3 would give me x cubed. And then if I evaluated the exponent on the 7, that would give me 343x cubed. Alright, so to raise a product to a power, raise each power to that power. So you're going to do the same thing you did up here, multiply any exponent that's inside. Alright, and I'm going to work a few examples to show you how to use this rule. Another rule would be if I have a quotient raised to a power, I do the exact same thing as if it were a product. I'm going to multiply the exponents inside, so 1 times m is m and 1 times m is m. Alright, so if I have 3 over 5 to the 4th power, there's an understood 1 on each of those. So 1 times 4 gives me 4, and 1 times 4 gives me 4, giving me 3 to the 4th over 5 to the 4th. And then if I use my calculator to evaluate that, I'll have 81 over 625. Alright, so to raise a quotient to a power, raise the numerator and denominator to that power. Now, if they have some other exponent, like if it were 3 squared over 5 squared to the 4th power, then we would get 3 to the 8th over 5 to the 8th. So the only way you can just directly raise it is if they already have a 1 there. Right? Otherwise, if you have something in parentheses with the exponent outside, you're going to be multiplying the exponents just like we did in rule number 1. There's no really difference except that what's inside the parentheses. A single base, multiple bases being multiplied, bases being divided. The power rule still holds. Multiply the power outside times all of the powers inside. Alright, now we're going to look at a couple of examples on each of those rules. Alright, if I'm using the product rule, here I have m to the 6th times m to the 8th. Since I'm multiplying, I'm going to keep my base m, and I'm going to add the two exponents together to get m to the 14th. Here I'm multiplying, so I have to consider the product rule. I'm going to multiply negative 5 times 6 times negative 3. That'll be negative 30 times negative 3 gives me a positive 90. And then I have like bases here with the r's. So I'm going to keep the r, and I'm going to add 3 plus 4 plus 1. Remember, this r has an understood 1. So that would give me a final answer of 90r to the 8th. Alright, if I'm using the power rules, alright, notice I have here a power raised to a power. I'm going to say 7 to the 15th power. Then you can use your calculator to evaluate that. Here I'll have 2, and I'm going to say 5 times 4 is 20. And then I'm going to say 3 times 4 is 12. So I'd have 2 to the 20th power. Using your calculator, you could evaluate that and get the final number, y to the 12th. Right here we would have 4 to the 15th over z to the 10th. Alright, and then you can use your calculator to evaluate 4 to the 15th. There's nothing I can do in the calculator with z to the 10th, so it just stays there. Alright, in this case I have multiple bases inside, so remember that 3 has a 1, so that would give me negative 3, and then a to the 6th. Alright, so I'll say 3 times 2 is 6. Then down here I'll have b squared c to the 8th. So 1 times 2, 4 times 2 will give me 2 and 8. Then if I simplify that out, 9a to the 6th over b squared c to the 8th. Right, the last rule I want to mention is the 0 exponent rule, and it just says if I have a base raised to the 0 power, that always equals 1. Alright, and that comes from another rule known as the difference rule, which says if I have like bases that are being divided, I'm going to subtract. And so if I say 6 minus 2, I would get y to the 4th. That's how the difference rule works. If you're dividing with like bases, keep the base and subtract the exponents, always subtracting the top one minus the bottom one. Alright, so if I came up and I divided y to the 6th by itself, alright, we know just from basic algebra that anytime you divide something by itself, it always equals 1. But if I apply the difference rule, the quotient rule, not the difference rule, go back up there and fix that. This is the quotient rule. Alright, that I would say 6 minus 6, which is y to the 0. So here I can take and relate that anything to the 0 power is 1, because to get a 0 power I have divided something by itself, and I've subtracted those exponents to get 0. So I can connect these two ideas together, that anything to the 0 power is 1, because getting a 0 power means I have divided something by itself. So if we look at some examples, 8 to the 0 power would be 1. Now pay attention to B and C, because if you put those in your calculator sees this as the opposite of 8 to the 0 power, which would be negative 1. But here the calculator sees negative 8 raised to the 0 power, which would be a positive 1. So your calculator is going to see those differently. Make sure if you're wanting to raise negative 8 to the 0 power that you put it in parentheses. So here we would have the opposite of 1, which so we get negative 1. Here we have the whole entire thing is in parentheses, raised to the 0 power would be 1.